Number 4, Part A. On what intervals, if any, is f increasing? Justify your answer. The function is increasing when its slope, which is the derivative, is positive. The graph of the derivative is above the x-axis on the interval from 2 to 4. So therefore, the slope is positive on that interval. Part B. Find the x-coordinate of each point of inflection of the graph of f on the open interval x is greater than -4 and less than 4. Justify your answer. The inflection points are found by taking the second derivative of the function and setting it equal to 0. Given the graph of the derivative, inflection points are where the slope of the derivative, the second derivative, changes sign from positive to negative or from negative to positive. There are inflection points at x equals -2, x equals 0, and x equals positive 3. Because the slope of the derivative changes from positive to negative at x equals -2, negative to positive at x equals 0, and positive to negative at x equals 3, those are the inflection points of the function.
This is part C, and the problem reads, find f of -4 and f of 3. Show the work that leads to your answers. So to get the original function from the derivative, you must take the integral, which is the area under the curve. And f of x equals the area under the curve of the derivative from the origin to point x.
Okay, so to find the position of the function, or f, at -4, you take the integral from -4 to 0. And you want the -4 to be on top, so to switch the limits of integration, you make the equation negative. Okay, and you have to incorporate the original position of the function, so you have to add f of 0 to the equation. Okay, so f of 0 is given in the original question, being -1. And to find the area of the integral between 0 and -4, you're looking for the area of this part of the graph. So to find that area, you have to take the area of this whole section, which would just be 2 times 4. Well, actually that's, yeah. 2 times 4. And then you subtract from it this part, leaving you with the purple. So that would be the area of a semicircle, which is pi r squared divided by 2. And it leaves us with 4 pi over 2, or 2 pi. Okay, so simplifying this down, you get -1 minus, because a negative times a positive is a negative. And then you have to make the area negative because it's under the x-axis. So negative 8 minus 2 pi. And then simplifying this even more, you get 7 minus 2 pi. For the second part of this question, we need to find the position of f at x equals 3. So, you need to find f of x, you need to take the integral of the derivative, as we said before. So, okay. And we have to include the original position, which is f of 0. So f of 0 is given in the original question, and that's negative 1. And to find the area of the derivative from 0 to 3, we have to take the area of this triangle and the area of half of this triangle. So that would be, so the area of this triangle is negative because it's underneath the x-axis, and the bases are 2, 2, and so 2 times 2, base times height, divided by 2 is the area of the triangle. And then you add the area of this half triangle, which is also a triangle. And so the base is 1, height is 1, so 1 times 1 divided by 2. And then you simplify it down. So you get negative 1, minus 2 plus 1/2. So you get negative 2.5.
So for part D, the problem says find the equation for the line tangent to the graph of f at x equals 3. The slope at x equals 3 is 1 because the y value for the graph of the derivative is 1 at x equals 3 up here. So what you do is plug in the slopes and the coordinates for x equals 3 of the original function. So it would be y minus a negative 2.5 from the slope you found in the previous equation for f of 3 equals 1 parentheses x minus 3 for the x value. And that's your answer. And if you're going to simplify it, you get y equals x minus 5.5.